I apologize in advance if the title of this video seems a little bit misleading. It says AutoCoder, but I'm not trying to build some sort of AI AutoCoder. I'm trying to find the solution to a problem that is very specific to my channel. It might be useful to you if you are doing some sort of coding presentation or if you have your own coding YouTube channel. So let me explain and we'll get started. Now you might wonder how we record these episodes. We mainly use two tools. It ain't much, but it gets the job done. We use Open Broadcast Studio, or OBS for short, to record our videos, our audios, the coding part that you see, and also anything that happens on the screen is captured through OBS in as clips. Now these are recorded as clips. All of these clips are edited into an episode using a software called Kdenlive. Kdenlive is the software that we use to do this. It allows you to basically place clips, overlay audio, put the mechanical keyboard sounds, and all of those things are essentially done through Kdenlive. The output of this, or the edited episode, is also rendered at the very end into a file that is uploaded into YouTube. All of our episodes follow a very specific pattern. There is an introduction, there is an explanation, there is the coding part, and then finally we show you the results. The coding part is the one that understandably takes a very long time to edit. All of this is of course edited in Kdenlive, and it takes a very long time to edit. And there are some episodes where there are so many coding parts that I'll have to capture so many different coding parts, finalize them. And then finally when I put it in Kdenlive, I'll have to sort of speed up the coding and then do a voice over them. Matching the voice to what is happening on the screen or how the code is basically speeding through itself is a challenge. And then finally, we add those mechanical keyboard sounds. The intent I have is to ensure that, I compress all of these three processes where I type in the code, where I then do the voiceover and then do the mechanical keyboard sounds, all of that into a single task. All right. And towards that end, I have sort of written a Java program that can do all of these three things for me. Allow me to explain. Generally speaking, the code that I want to type during an episode is already prepared by the time I'm ready to record. And that's very necessary because preparing the episode beforehand allows me the luxury of doing a lot of trial and error. Now, if you remember our previous episodes, we used to do the coding live and we had a lot of errors into them. And I think that made for a very boring episode. But contracting all of these into very short coding clips, I think makes the episodes much more watchable, and they're of short lengths also, bearable lengths also. Now, since I have the code ready beforehand, shouldn't there be an easier way to just take the existing code and make it seem as if it is being typed on the screen? Now there are ways to do it. For example, there is a class available in Robot that is actually purpose built for this one. Not for this, but it generally says that it is for the purposes of test automation, self-running demos, or other applications where control of mouse and keyboard is needed. That's what it says, all right? And it has some methods in it where I can do key presses, key releases, mouse move, mouse press, all of that. So I can basically use the java.awt.robot class to take an existing source code, convert each one of those words into single letters. take character by character and then send in the key codes for that. Now let me tell you beforehand, that did not work at all. Now offline, what I did was I basically tried to use the java.awt.robot class to basically just take a source code and then retype it automatically. And that didn't work out because the characters that are used to actually form the source code are different from the key codes that you see that are required as parameters over here. So it didn't work out at all. So what's the alternative? I built a program in Java just to solve this issue. The program can read a Java file or a JavaScript file and type it out in a Java window. But remember, syntax highlighting is a very important part of the coding process. Here it is in action. Here we go. I've had the program type out an old JavaScript file automatically. The syntax highlight is per expectation. The program also gives me a mechanical sound that matches the typing. Now, if I click on the screen, the coding is paused. This will allow me to, of course, explain the parts of the code that might be very important. Clicking on the screen again will resume the coding. Now let's look under the hood and see the code behind this program. All of the aspects of the AutoCoder program is controlled by the AutoCoder.properties file. The entries are self-explanatory and pretty straightforward. For example, the fonts that you see for it to auto type are controlled by these two, the font name and the font size. You can control it any way you want, but I'd recommend that you use monospace fonts. The colors are also defined over here. The colors are all supposed to be hexadecimal colors. For example, the comment is supposed to be this color. This is actually the color that you see for all of the comments. So I've basically reused the same hexadecimal colors. There are colors for numbers, strings, special operators, statements, constants, and so on and so forth. But most importantly, how does the program know where all of the syntaxes are? What are all the keywords? What is a string? Where are all the constants? That is defined in another property called the format file. Now, for example, I wanted to type out a JavaScript file over here. So I have used a file here, or I have defined a file here called javascript.properties. Let's look at that for just a moment. It defines all of the things that it needs to basically syntax highlight a JavaScript file. Things like what are the special operators, statements, constants, literals, they're all defined over here. Now, this goes on and on, defining every available object that is there in JavaScript. I've also defined a file for Java as well, where I have the literals define the objects. The objects basically make up the bulk of all of the Java, all of the Java syntaxes. Then there are reserved words, but there is no need for any other properties in the case of Java. So that's generally how this program works. Now, apart from the format file, there are also things like the typing speed. Now, in a lot of episodes, I actually can rush through a specific coding part, or I can slow down, and that can be controlled by this typing speed. All right. I can also say if I can mute or if I can keep the mechanical keyboard sound. I can control it with this property, and I can also define how loud it can get. Now there is also this frequency thing. There is also this frequency property, and the reason why I have that is because if I was to, let's say for example, make this as 1. Let's see what happens if I make this as 1. Here we go. Now it might seem that there are a lot of keyboard sounds, all right, that too many keys are being pressed. But this is actually the correct sound. What is happening is that because I made the frequency as 1, it's giving out one mechanical key sound every letter it types. Now, the reason why you hear so much mechanical keyboard background noise happening is because we are typing so fast. That's the explanation for it, which is why I introduced that property. So we'll set the frequency back to 5, so what this means is that one mechanical key sound would be made for every 5 letters that are typed on the screen. That's the meaning of this. Now, I'm not going to do any coding in this episode. I just wanted to show you the highlights of this program to sort of show you how this program works or how it works. All right. So to begin with, we have properties. We load the properties using the properties.load function. These are all inbuilt into Java, and this sort of creates a key value pair out of all of the properties that are in the dot properties file. All right. Then I load all of the properties that are in the file into specific variables. Now these variables would be used throughout the program, and for that reason I have made these variables all public. I have made their access all public so that they can be used throughout the program. Now the main chunk of the work of typing it in the on the screen is actually done by a file called coding canvas, which extends from a JPanel and also implements the runnable. Now, if you already know Java, runnable is how you make multi-threaded programs. All right, let's look at the constructor of this program. And what it does is it first loads the file that needs to be typed. All right, so if you have a JavaScript file, you can pass it over here. It needs to be passed. And once it is passed, I also format it. What do I mean by formatting? Let's look at the format file function itself. Remember those special operators and statements and constants that are there in the properties file, in the syntax properties file. So let's just take at JavaScript syntax properties file. All I'm doing is I'm taking, let's say, for example, all of the special operators declared over here, statements like delete, function, all of those things need to be sort of highlighted in the special operators color. So I just take all of the values that are present over here, search for them throughout the file, using this regex, using this regular expression. I search for them throughout the file, and then I sort of surround them with these characters. All right, what these characters are not important, but they sort of make up my own markup language. Just like how HTML is a markup language, what I do is I take these keywords, these keywords, statements, constants, I take them and I just surround them by these characters, by these very special characters. These special characters are characters that lie outside in the ASCII key table. All right, so that's all that these things are. And they sort of work like a markup language for me. Now, why is this important? Because when I actually render them on the screen, on the canvas itself, I have a function over here called start typing that sort of initializes the graphics 2D, and it starts to paint the component, or it starts to paint it on the screen. And how does that work? I draw everything on something called as a buffered image. We'll go to that function in just a minute. But the buffered image itself is actually written right over here. All right, and let's go back. Yes, so I have a function over here called draw on the buffered image, and all it does is it takes the file character by character. If it finds that it's one of those special characters, then it actually doesn't put it on the screen, but it sets the color to a specific operator color or statement color or constant color. These are the colors that you find in the properties file. All right. So if it finds that the markup is a specific thing, if it finds a specific markup character, then it sets it to that color. And if it finds that the character has ended, then it sort of sets it back to the regular color. And after that, all I have to do is sort of draw that character on the screen, move my cursor to the next, to the next letter, and then move on. And then at the very end, I just play this mechanical keyboard sound. So that's how this program works. So those are the two main aspects of this entire program. One is we'll have to load the file, format the file, and then type it out on the canvas itself, character by character. And for every character, we start to play that mechanical keyboard sound. So that's all I had to showcase for this episode. And AutoTyper, for me, that would be a game changer. I will be starting to use this from our next episode onwards, so keep a lookout for that. All of this would be uploaded to GitHub, of course, as usual, and I'll leave the links for the GitHub in the description. Let's see it in action one more time. This time, a Java file, and we'll say our goodbyes. Here we go. So Java uses a different color scheme set, I hope the sound is actually coming through. I've made it a little bit low. But that's about it. That's all for this episode. Thank you so much for joining. See you again next week.